We are Group 3, and today we will be discussing volume measurement as well as the different volumetric vessels and tools used in accurately measuring volumes in various applications. But first, let me give you an idea of what is a volume measurement. Volume measurement refers to the quantification of the three-dimensional space that an object or substance occupies. It is typically expressed in units such as cubic meters or liters and is crucial in fields like engineering, manufacturing, and science for accurate material handling and analysis. But before that, let me first introduce to all of you the members of the group. We have here Aliana May Bederico, Mark Luis Catapang, Daniel Samantha Liave, Janry Munoz, and yours truly, Yumi Menes. And now let me call on Miss Aliana for our icebreaker.
Wait lang po. So for our icebreaker, let's play Rebus Puzzle. So ang Rebus Puzzle po is riddle-like po na merong mga merong mga words na nakapaloob sa isang ah, ano ba tawag dito? Sa isang puzzle. So example po is eto. So Dancing in the Rain. So let's play po. So first, who wants to answer po? Wait, sino yun? Sige po, nag-raise hand po.
Understood.
Hindi po. Malapit. Sige po.
Misunderstood.
So tama po. Misunderstood. Next. Who wants to answer po? Sige po. Trisha.
Advice.
Tama. Next po. Who wants to answer po? Dave. Eiffel Tower. Tama. Next po. Vincent? Sinin?
Eggs.
Hindi. Walter.
Scramble eggs.
Tama. Last na ba to? Next po. Sino pong gusto sumagot? Sige po. Sinin? Trisha.
Long time no see.
Tama. So, yun lang po. Thank you po.
Three-dimensional mathematical shapes are also assigned volumes. Volumes of some simple shapes, such as regular, straight edge, and circular shapes, can be easily calculated using arithmetic formulas. So, volumes of complicated shapes can be calculated with integral calculus if formula exists for the shape's boundary. One-dimensional figures such as lines and two-dimensional shapes such as squares are assigned zero volume in the three-dimensional space. Volumetric vessels and other tools. Sorry po, naglalag po ang aking internet. Nasaan na ako? Various laboratory vessels and devices are used for preparation of solutions and manipulation with liquids. They differ in the intended use and accuracy. Precise volumes must always be measured at constant temperature because, due to the thermal expansion, changes in temperature are followed by changes in volume. For example, water at 10 degrees Celsius has much smaller volume than 80 degrees Celsius. And these are the devices used in laboratory to measure volume of liquids and their corresponding capacity and accuracy level. Now, as for Erlenmeyer flask and beaker, it is not suitable for measuring precise volume of liquids. They are only suitable for approximate volume of liquids.
The first that we will be discussing is the beaker. Beakers are used for approximate determination of the volume of liquid and thus are not necessarily classified as measuring tools. They are used especially for dissolving compound, diluting liquids, heating, and other operations. Beakers are unique for their peak that is used to pour liquids. Because of low accuracy, they are frequently not classified as volumetric devices. For further explanation of the beaker, we provide a video, and after watching the video, we will be asking a question.
Measuring cylinders are used to measure.
First of all, let's look at beakers. On the beaker, we have graduations that are the various volumes that we can measure. One of the things that we have to be careful of is that each vessel that we put a fluid into has some air. For instance, this small beaker is a 50 milliliter beaker, and the 50 milliliters would go right to the bottom of the spout where you pour it out. Now, 40 milliliters is the highest that is actually on the graduation. And it says right below the 40 milliliters, plus or minus 5%. That means that we have a possibility of having a 5% error in any one of these graduations. And one of the reasons we do that is, or have that error, is because we measure using a meniscus. Typically with water or most liquids, there is a adhesion of the water to the side of the vessel, and it actually makes a concave surface. And we measure along the bottom of that surface. If the bottom of the meniscus, the bottom of that concave surface area is right at the line, then we know we have right at that volume. But there is, on this particular vessel, a 5% error. Now, if we move up to the next size, which is a 150 milliliter beaker, again, 150 milliliters is at the bottom of the spout where we pour, and 140 is where we stop with the graduations on the side. Now, there is no air indicated on this particular beaker, so we have to determine what is our potential for air when we fill a fluid in here. And one of the things that is a general rule is for each graduation here, that is considered to be your air. So we have 140 here, 100 here, and halfway between is 120. So we have the potential to have a 20 milliliter air. Now, if we measure the bottom of the meniscus and it's very close to the 140 mark, obviously we don't have a 20 milliliter air, but there is still some air involved when we're measuring. Now, the next vessel that we want to look at is much more precise, and it's called a graduated cylinder. We have graduations on this particular cylinder where we have 10 graduations in between 20 and 25 here, for instance. That would be 21 at the next line, 22, 23, 24, and then we hit the 25. But we can actually do 20.5 or 20 and a half milliliters on here. Now, this has a TD on here at 20 degrees Celsius, which is average room temperature. What that means is this is designed to deliver, TD for to deliver that particular volume. So on this, our air is not listed on this, but we would assume that our air is 0.5 or 1/2 of a milliliter. Let's look at another vessel that is commonly used in the laboratory, and this is called an Erlenmeyer flask. Erlenmeyer flasks have graduations on the side, but they're not very accurate. Again, we have 20, 30, 40, 50, but nothing in between. So we can't determine where 45 or 35 or even 38 would be on an Erlenmeyer flask. So this is a less desirable vessel for getting very accurate measurements. And these also come in a variety of sizes. Now, let's talk about a very specialized type of vessel. This is called a volumetric flask. And if you look, it says 100 milliliters. That is the only volume that's on here. And this is designed to contain at 20 degrees Celsius. Not to deliver, but to contain. And we have a scored graduation at the top of the neck of the flask that tells us where the 100 milliliters is. This vessel contains exactly 100 milliliters. There's very little chance of error when you're talking about using a volumetric flask. I have one here in 100, 500, and 1,000 milliliter sizes.
Engineer Hoso, nandito ka ba?
Yes po. Bakit po?
What do you think to watch out when using a beaker?
Pakiulit nga po, ang ingay po ng aso ng kapitbahay namin.
What do you think to watch out when using a beaker?
Ano po, kapag po when using a beaker, kailangan pong tandaan na a beaker is not an measuring tool it's not an accurate tool for measuring volume since yung measurement po ay meron pong large gaps.
Thank you, Engineer Hoso. Next is the volumetric flask and cylinders. Volumetric cylinders and volumetric flasks are used to measure volume of liquids contained in them. They are calibrated for volume included in them. This is indicated by marking IN. The liquid has accurate volume when it reaches the corresponding marking on the scale. Volume is usually indicated in ml. During measurement of the volume, the vessel must be placed on an even horizontal support. Next slide, please. The required volume is measured when the lower edge of meniscus of the liquid just touches the marking on the vessel. Cylinders are less accurate. Volumetric flasks are used for preparation of solution of exact concentration. Cylinders are used for measuring volume. They are not employed for dissolution, dilution, or mixing. We also prepared a video for this.
To make a solution using a volumetric flask, the first step is to rinse your flask with some of your solvent. Once that's done, you then want to take your known weighed mass of your solid sample and dissolve it in a small amount of your solvent to make a highly concentrated solution. Once all of your solid sample is dissolved, use a funnel to pour the concentrated solution into your flask. It's a good idea to then rinse this beaker with some of your solvent to ensure that all of your compound has been transferred. Once that's done, you can then fill the flask with more of your solvent. Be sure not to fill too quickly or you run the risk of moving past the calibration mark. Once you're about a centimeter below the calibration mark, use a pipette to fill dropwise the rest of the way so that the bottom of the meniscus is at the line. Once that's done, cap the volumetric flask and invert at least 10 times to ensure that all of the compound is evenly distributed throughout the solution. After all of your 10 inversions, you may notice that your meniscus is no longer quite at the calibration mark. This is because some of your solution has been caught up in the cap, but that's okay. Adding any more solution at this point would change the actual concentration of the solution. If you already have a concentrated solution set up, you can simply transfer a known volume of a known concentration using a measure and pipette.
Measuring cylinders are used to measure volumes of liquids relatively accurately. They come in a range of different sizes and types, and it is important to choose the correct size for your purpose to ensure the most accurate measurement. The volume of a measuring cylinder is marked with graduations. The measuring cylinder should be placed on a flat surface and should be viewed at eye level as you pour the liquid in. The measurement should be taken from the bottom of the meniscus as shown on screen. It can be quite difficult to get the correct volume first time round. A pipette can be used to add the last few drops if required. Also, if you accidentally overshoot the required volume, you can remove the excess using a pipette. Remember, you should not put liquid you removed back into the original container, so as to avoid contamination. Do not lift the measuring cylinder while you pour liquid into it, as this increases the risk of accidents.
Parola.
Hello po.
The question is how to properly measure the liquid solution when using a measuring cylinder.
Wait lang po. Bale, the measuring cylinder should be placed on a flat surface and should be viewed on the eye level po.
Thank you, Engineer Barola. Engineer Gamelia.
Yes po.
How to accurately get the bottom of the meniscus of the calibration line of the volumetric flask.
Based po dun sa video, ipo-pour yung solution dun sa flask using a funnel. Then, kailangan mag-stop right before ma-reach yung calibration line. Then, gagamit ng pipette para ma-reach yung calibration line.
Thank you, Engineer Gamelia. Next is the burets. Burets are used for titration. Or whenever the same liquid is repeatedly measured, burette is a glass or plastic tube with calibrated scale. Forty-two burette is attached to a stand in a vertical position with a closed when it is filled with the measured liquid. Some liquid is the outpour so that the meniscus touches, marking up the scale. Now burette is ready for titration. Next slide, please. The liquid outpour with the stopcock and the volume. Read on the scale, the most important movement is reading the volume with burette. The volume is always read twice, first to read the starting position of the meniscus and second time to read the end position. As the difference in volume is calculated, it is not important how exactly the volume is read. It must, however, be read in the same way every time. For better explanation of burettes, we provide an example, a video of this.
Welcome to ISU GenChem Lab Tutorials. In this lesson, we'll learn how to use a burette. We'll begin with the parts of the burette. At the very bottom is the tip, to which liquid flows out. Above the tip is the stopcock, which allows us to very carefully regulate the flow of the liquid. And above the stopcock is the barrel, which is marked with graduations. Notice at the very top of the barrel is the 0 milliliter mark, and at the very bottom of the barrel is the 50 milliliter mark. Before we begin, it is good practice to first clean and then rinse the burette. To clean, we'll pour a few milliliters of deionized water into the barrel, making sure the stopcock is in the closed position. Then turn the burette into an almost horizontal position. The deionized water should then slowly flow towards the top of the barrel. Holding this position, rotate the burette, which will efficiently coat the insides of the barrel with the deionized water. After 5 or 10 seconds of doing this, let the rinsing water drain into our waste container, and then repeat this cleaning step with 2 additional small volumes of deionized water. Next, use your solution to rinse the burette in a process otherwise identical to the cleaning step. Repeat this rinsing process 2 additional times with small volumes of your solution. To fill the burette, you may choose to either pour your solution from your small container into the top of the barrel. Alternatively, you may decide to use a small funnel inserted into the top of the barrel to make this process a lot easier and certainly a lot less error prone. Either approach is perfectly okay, but if you decide to use the funnel, please remember to remove it before continuing. Once it is filled, secure the burette in the upright position using the burette clamp. We'll now take a closer look at the operation of the stopcock. Notice that when the stopcock is perpendicular to the barrel, it is fully closed. When the stopcock is parallel to the barrel, it is fully open. And when the stopcock is positioned in between parallel and perpendicular, we have fine control over the flow rate of the liquid. At this position, we have a nice slow drop-by-drop control. And if we turn the stopcock a little closer to parallel, we have a fine steady stream of liquid. Once again, a slight turn towards the perpendicular position allows us to resume the drop-by-drop control of the flow rate. We are now ready to read the initial volume of the burette. First, position yourself such that you are eye level with the meniscus to avoid parallax error. We see that the meniscus is between 5 and 6 milliliters. Further, it is between 5.6 and 5.7 milliliter marks. And finally, estimated to the hundredths place, I record the initial volume as 5.67 milliliters. After some of the liquid has drained out for the experiment, we're now ready to read the final volume of the burette. Meniscus is now between the 11 and 11.1 milliliter marks, and finally estimated at the hundredths place, I record the final volume as 11.04 milliliters. The volume delivered in my experiment then is the difference between these two readings, 11.04 and 5.67 or 5.37 milliliters. When we are finished with the burette, first allow the solution to fully drain out of the burette, including the tip, and then clean it as before with 2 or 3 small volumes of deionized water. Finally, hang the clean burette upside down with the burette clamp, making sure that the stopcock is fully open to allow the burette to dry most efficiently.
Engineer Aguila, nandito ka ba? How to read the volume of the burette? Thank you, Engineer Aguila.
Now we will head on to the glass pipettes. Today, glass pipettes are rarely used in contemporary routine laboratories. Glass pipettes were replaced by semi-automatic dispensers. The volume of glass pipettes may vary from 1 to 100 milliliters. Glass pipettes can be non-scaled for measuring of a certain volume or scaled with grades by 1 milliliter and tenth of milliliter. Numbering of scale can go from the tip up or in the opposite direction. For security reasons, a liquid should never be aspired by mouth. Various adapters and pistons are used instead. When aspiring the solution, the pipette should never touch the bottom of the vessel. Before measuring a sample, the pipette should be filled with the solution first and the liquid is then thrown away. Then the exact volume is measured and delivered for further processing. The measured solution must never get into the adapter.
Volumetric pipettes are glass or plastic tubes, usually between 1 and 100 milliliters. Used for accurate measurements, volumetric pipettes are calibrated to deliver only one specific volume. The specifications of a volumetric pipette are usually imprinted on the pipette itself. The specifications indicate how much liquid will be transferred if the liquid is drawn up to the calibration line on the neck, the temperature at which the calibration was made, and whether it is a TD or a TC pipette. TD means that the pipette is calibrated to accurately deliver the specified volume of liquid. TC means that the pipette is calibrated to contain the specified volume of liquid with no remainders. To begin, the pipette should be inspected for cleanliness. If water beads up or collects on the inner surface, the pipette is not clean. Follow a cleaning procedure or obtain a clean pipette. Pour the liquid to be pipetted into a beaker. Make sure there is sufficient liquid to fill the pipette and to rinse 3 times. Using a pipette bulb, draw up a small quantity of the liquid to be pipetted and thoroughly rinse the entire interior surface by rolling the pipette horizontally with a slight rocking motion. Drain the rinsed liquid into a waste beaker. Repeat the rinsing procedure at least 2 more times. Using the pipette bulb, drop the solution into the pipette until it is filled to about 2 to 3 centimeters above the graduation mark. Remove the bulb and quickly place your forefinger over the top of the pipette stem. Make certain that there are no air bubbles in the bulk of the liquid or foam at the surface. Tilt the pipette slightly from the vertical position and wipe the outside of the lower stem with lint-free tissue to remove any adhering liquid. Hold the pipette vertically with the tip touching the inner wall of a waste vessel and slowly allow the liquid level to drop by slightly decreasing the finger pressure, halting further flow when the bottom of the meniscus coincides exactly with the top of the graduation mark. The pipette must be held vertically with the mark at eye level. Move the pipette to the receiving vessel with the pipette held vertically and the pipette tip touching the wall. Allow the sample to drain freely. Once the liquid appears to be completely drained, leave the pipette for an additional 5 seconds by counting to 10. Do not blow or shake out the small amount remaining in the tip, as the pipette is calibrated to deliver a specified volume with a small amount remaining. To review, the steps are: first, inspect the pipette for cleanliness and rinse the pipette with the liquid to be pipetted. Use a pipette bulb to fill the pipette above the graduation mark. Wipe the outside of the pipette using a lint-free tissue to avoid contamination. Drain the liquid until the bottom of the meniscus sits on the graduation mark. And lastly, drain the sample into a receiving vessel, retaining the tip of the pipette on the wall of the receiving vessel for 5 seconds.
So for the question, Mr. Engineer Romero, are you here?
Yes po, good evening.
For the question, how should a pipette be positioned with transferring a solution?
according po dun sa video ay dapat po yung pipette is held vertically tapos po yung tip ay nagtatouch sa inner wall ng container kung saan isasalin or ita-transfer yung solution.
Thank you for your answer. Next slide. So now we have microsyringes. Microsyringes serve for dispensing small volumes from 0.1 to 1,000 microliter of liquids. They consist of a needle attached to a scaled glass cylinder with a piston. Different types vary in the diameter of the needles and pistons. We have a video for this.
NanoFill is a low-volume syringe for improved microinjection in mice and other small animals. It makes quantitative nanoliter injections much easier and more accurate than any other method. NanoFill is a 10 microliter syringe, and the NanoFill 100, which I have on here, is a 100 microliter syringe. The volume of the larger syringe is useful for applications that require multiple injections. The speed of the larger syringe can be 10 times faster than that of the NanoFill 10 microliter syringe when it's used with the UMP3 Ultra micropump. The limitation of the 100 microliter syringe, though, is that the injection volume resolution is lower than that of the 10 microliter NanoFill syringe. The design of the needle reduces the needle size and the dead volume of the system. The smallest metal needle offered for NanoFill is our 36 gauge stainless steel needle, which is so small that it can be inserted into the 33 gauge needle. That's what you're looking at here. And it is offered in both beveled and blunt styles. In traditional nanoliter injection, the dead volume of the syringe and the needle is backfilled with oil as a transfer medium. This makes the process messy and risks contamination of the injected sample. NanoFill's low volume eliminates the need for oil. Injection is now simpler and less messy, and there is no possibility of oil contamination in critical applications. If you have any questions, just give us a call.
So after watching the video, here is the question. Mr. Sevilla, are you here? Engineer Sevilla.
Hello, good afternoon.
For the question, what is the advantage of a larger volume microsyringe?
I think the advantage of a larger volume microsyringe is that it is useful para sa application kung saan maraming injection ang kinakailangan.
Thank you very much. And now we have piston dispensers. Piston dispensers consist of a piston with a scale attached to a flask. They are intended for repetitive dispensing of the same volume from a stock container. Dispensers designated for measuring aggressive liquids, or example is strong acids, are made of borosilicate glass. Plastic parts that are in contact with the measured liquid are made of PTFE, and other parts of PE and PP, or PP. Electronic control modules may automate dispensing in contemporary dispensers. Next, we have a video to further expound this tool.
The bottle top dispenser is a useful tool for your laboratory in dispensing reagents and chemicals accurately and easily. There are various models available with different volume ranges. Each includes 5 adapters to fit different size bottles. All wetted products are made from PTFE and borosilicate glass. for maximum chemical resistance. It includes a chemical compatibility chart, so you have a better idea of what chemical you are allowed to put in and which ones are not recommended. Each model includes a calibration report, as well as a 7-step checklist. You can purchase the pump only, or you can buy a set which includes a glass media bottle as well. The parts are easy to disassemble and to autoclave. If needed, there's also a calibration tool included. You just pop the cap off the end, and you can insert this to recalibrate your pump if it is ever off. Assembly is very easy and straightforward. I find the appropriate adapter that fits my media bottle. I adjusted the height of the straw so it reached just the bottom of the bottle. Then you just put them all together. Your bottle dispenser is all set up. Let's go and look at the different controls. The range of the bottle dispenser is indicated along the side, as well as a simple knob that indicates lock or unlock. You would turn this so that you can adjust the height or the volume that you want to dispense, lock it in place. Then as you lift up, it will draw up the solution to that specific volume, and then when you press down, it dispenses it. One important note, when you are using this for the first couple times, the system is empty. So you want to prime the pump by drawing up liquid and dispensing it several times until there is liquid throughout the whole system. So if you just put this together, your first few pumps will not be that accurate. I primed the pump and I had this set at 15 milliliters. So I'm going to pull this up firmly but gently. When you feel resistance, you want to stop. That's 15 milliliters that I've pulled into the dispenser. If I simply press down, I should be dispensing out exactly 15 milliliters of my solution. Here are some specifications of the different models.
So for the question after that video, I would like to ask Engineer Gomez. Engineer Gomez, are you here? No, that's Engineer Gomez. Sino? Tatanong. Arabic. Engineer Donay, are you here? Absent ata si Engineer Adonay.
Yes po, yes po.
Ayan, and present si Engineer Adonay. Engineer Adonay, my question to you is how to use the piston dispenser?
To properly use the piston dispenser ay ano po, yung pipiliin mo yung tamang volume na i-dispense mo, and you must lock it on the slider po. Then start to pull the top of the dispenser until ma-feel mo yung resistance, and finally push down yung and dispense the volume of the solution po.
Nice. Thank you very much.
For the next tool, pipetors, according to the way of operation, manual and electronic pipetors can be distinguished In manual pipetors, the piston is moved by a thumb using an operation knob. Accuracy and precision of pipetting depend on expertise of the operator. In case of electronic pipetors, the piston is moved by a small electric motor. Different speeds of aspiring and expressing of the liquid can be selected according to the properties of the pipetted solution. So pipetors is also known as pipettes, are laboratory tools used to measure and transfer precise volumes of liquids. They come in different designs, but the basic function remains the same, is to draw liquid into a narrow tube and dispensing it in controlled amounts. So according to the principle of operation, pipetors can be divided into two big groups: the positive displacement pipetors and the air displacement pipetors. For the air displacement pipetors, next slide please. For the air displacement pipetors, principle of so-called air cushion is employed in this type of pipettes. A certain volume of air is between the piston and measured liquid. The volume of solution of the air aspired or expressed with the piston may differ. It depends on the density and viscosity of the liquid, wettability of the surface of the tip with the pipetted liquid, temperature, atmospheric pressure, and other influences. Thus, every pipetor must be calibrated on a regular base. So sa air displacement pipetors po, they are highly accurate and versatile, suitable for handling aqueous solution and many standard lab applications. However, they struggle with highly viscous, volatile, or foamy liquids as their air cushion can be affected by by these factors po, leading to variability in volume measurement. So for better understanding po, here is the video presentation.
In this short video, we're going to look at how to use an air displacement pipette. With a pipette tip fitted, push down to the first stop, place the tip in the liquid and slowly bring up your thumb. Move over to the other container, push down to the first stop, pause and then push all the way through as far as you can. Again, draw up the liquid slowly, having pushed the plunger to the first stop, over to the other container, push down to the first stop, pause. The same action is carried out with a P200. Down to the first stop, into the liquid, bring your thumb up slowly, over to the other container, push to the first stop, pause and then push further down. The P1000 can be set to the desired volume by rotating the black wheel at the top. Here we are setting it to 1 mil. The P1000 will read 100 when at 1 mil. P200s and P20s, for example, are set in the same way by rotating the black wheel at the top, but in this case the number in the window reads the exact volume. In this case we are setting a P200 to 200 microliters. So push down to the first stop, put the tip in the liquid and then bring your thumb up. Push down to expel the liquid and then push all the way down to remove excess. So the plunger, you push down to the first stop, tip into the liquid, bring up slowly, push down again to expel the liquid and then push through to expel excess. Here we can see the liquid being taken up into the pipette tip, transferred over, pipette, plunger is pushed down to the first stop, brief pause and then push through. Here you can see the actions together. Plunger comes up, liquid is taken in, we move over to the other container, push down to that first stop, pause briefly and then push through. Same action with a P200. Push down, pause, push through.
So, Engineer Panopio, are you here?
Hello po, hello.
So, may I know what's your idea on how to adjust the volume that the air displacement pipette will take?
Para po ma-adjust ay iikot lang po yung wheel sa top ng pipette habang ina-adjust yung measurement sa gusto mong amount ng volume. Yun lang po.
And of course, to sum it all, volume is the amount of space occupied by a substance, solid, liquid, or gas. It is typically measured in cubic meters in the SI unit system. Simple geometric volumes can be calculated with arithmetic formulas, while more complex shapes may require calculus. Next, various laboratory devices like beakers, flasks, burettes, and pipettes are used for measuring liquids. Accuracy varies depending on the tool. For example, volumetric flasks offer high precision while beakers are used for rough estimates. And lastly, volume measurements must be done at a constant temperature as liquids expand or contract with temperature changes. Most volumetric tools are calibrated at 20 degrees Celsius or 25 degrees Celsius. For measurement techniques, volumetric flasks or cylinders provide precise liquid measurements by reading the liquid mensus, and for beakers, used for rough volume estimates and mixing. For burettes, it is primarily used for titrations, allowing repetitive, accurate volume readings. For pipettes, glass pipettes have been largely replaced by semi-automatic devices but are still important for measuring small volumes. And for microsyringes and piston dispensers, it is used for very small volume dispensing with microsyringes operating at zero point 0.1 to 1,000 microliter precision. Do you have any clarifications? Questions? Or any reactions? Okay, so if not, we will the assessment will be sent on our group chat, and that is all. Thank you everyone for listening.
So ayan po, congrats sa nag-present. So bala nangyayari po is after natin after the presentation of temperature measurements, we will have discussions. So ako naman ang mag-discuss and we will focus on the problem solving of each parameters like pressure, temperatures. We will focus also in mass and weight measurements and other parameters na na-discuss natin these midterms. So before the midterm exam, we will have a face-to-face discussions for all the parameters discussed. And I will share some calculator techniques and some functions on your calculator. Kaya, engineers, always bring your calculators. Naintindihan po, engineers.
Yes po, sir.
Yes po, sir.
So,
Yes po, sir.
again, hinayaan ko na makapag discuss kayo ng key concepts about different parameters, iba't ibang measurements, instrument, and apparatus. And ang sa aking part is yung problem solving talaga. Ano? Naintindihan po, engineers? Kasi mas maintindihan po
Yes.
kung kayo mismo ang mag-explain kung ano ba yung bawat instrument na ginagamit sa iba't ibang parameters. Ano? So kung hindi man kayo nakinig, let's say hindi kayo nakinig sa ibang grouping, sa ibang groups, so at least alam ninyo yung inyong pinaresent. Ano? So compare na ako yung magtuturo ng mga key concept diyan sa inyong module. So most probably marami sa inyo hindi makikinig, ano? Kasi online. So sa ganitong setup po mga engineers, 100% matututo kayo pagdating sa problem solving. Ano? And tutulungan ko kayong ma-develop ang inyong problem solving skills and pag-a-analyze ng iba't ibang problem sa face-to-face. So, any concern, engineers? But for the next meeting, kailan po yun?
Thursday po.
Let's talk about temperature na, no? So, sino yung next group po? Ayun. So, be ready na lang po sa next meeting and then sa face-to-face class, mag-ano po tayo, problem solving. So, may pinrepare po ako doon na around 100 items ata. So, sana masolve po natin lahat. Any concern, engineers?
Wala naman po.
Ayun. And again, yung quiz 1 ninyo, don't forget, kailangan natin yan. Yung knowledge ninyo, doon sa agalahams, ano ba yung agalahams, yung conversion, sobrang mahalaga po yan. Yan po yung kailangan natin isa sa mga foundation para po sa problem solving. Ano? Tindahan po, engineers. Sige, yun lang po and God bless. Again, thumbs up po para sa mga nag-present. God bless.
Thank you po.
Thank you.
Thank you po.
Thank you po, sir.
Thank you po.
Thank you po.
Thank you po.
Thank you po, sir.